Many of my clients they ask, why can't we use nitrite, that is sodium nitrite salt in the single pack phosphating, especially in the stock solution? My clear cut answer is no. Let me explain why it should not be used. First of all, let me check the feasibility. Okay, if I agree that sodium nitrite can be used, means it should be stable in acidic solutions. And in such a way, the solution should be well buffered and it should be totally free from any reducing agents. It is commonly used as an accelerator as a separate pack. Do you know the reason for this? Because if you use nitrite in a single pack system, the instability is a basic problem over long storage. And not only that, there is a risk of decomposition and thereby a releasing of various types of nitrogen oxide gases. So that is why it is not recommended to use nitrite in the single pack. Suppose if you want to use it, the formulation should be in such a way that it should be well buffered and it should be totally free from reducing agents. And not only that, there are some restrictions of using the type of surfactants. Okay, because this nitrite will definitely behave differently with the surfactants, especially with the anionic surfactants. Now, uh, let me that is look into that uh, deeply further. See, what are the challenges in single pack integration? First of all, the oxidation of surfactants and some of the organic chemicals loaded in the phosphating system. So here the nitrite reacts with some anionic, in certain cases non-ionic surfactants also, especially with ethoxylates, and definitely it will cause some yellowing color. Then it will give some odor also, some smell also. Then secondly, let us discuss about this nitrite decomposition. Under low pH, that is acidic conditions, this sodium nitrite, that is NaNO2, that decomposes in order to release the toxic, that is nitrogen oxide gases, whether it is NO or NO2. Okay, and thereby it loses its accelerating ability. Thirdly, the reduction of shelf life. For instance, when it is mixed with, that is, this nitrite is mixed with metal salts like zinc, manganese, nickel, especially in the case of a trication phosphating system where you have got the zinc, manganese, and nickel cations, and with the phosphoric acids, nitrite will definitely degrade within 4 to 6 weeks unless stabilized. So it should be properly stabilized. And if you do not know how to maintain the buffer, then definitely do not use the nitrite in single pack system. Not only that, it will form sludge even during the storage itself. And this decomposition can result in salt deposition and that causes sludge even in the storage, that is warm storage. Okay, then let me move to the next aspect, that is, suppose I must use nitrite in a single pack. There is no other go. I want to include this one. Then in that case, I would like to suggest the following guidelines. pH buffering, and then stabilizers, use of stabilizers. Then you have to improve the storage conditions. Then as a fourth aspect, that is, you should have short shelf life labels also. You must indicate better, you should have such type of arrangement. Then surfactant choice is restricted here. Now let me discuss one by one. For example, in the case of a pH buffering, always you have to maintain the concentrate pH around 4 and 5, 4 and 4.5. And in that case, you can use sodium hydrogen phosphate. Okay, sodium dihydrogen phosphate. Don't use this sodium phosphate, sodium dihydrogen phosphate. Sodium phosphate is Na3PO4, that is Na3PO4, that is sodium phosphate. Sodium dihydrogen phosphate means that is NaH2PO4. So that makes the difference. And you have to use borate buffer also. Then, as far as the stabilizers are concerned, you need to add some small quantities of sodium benzoate, otherwise some antioxidants in order to reduce the nitrite degradation. So that because we have to stabilize our stock solution. Then, regarding the storage conditions, always that is keep away the stock from heat and sunlight. And you can use HDPE drums and with vented caps also. Then you should have short shelf life label indication. So you can put a label on the container stating that that is used within 4 to 5 weeks, 4 to 5 weeks. Otherwise, prepare concentrate fresh before the dispatch. So this is the way you can maintain. And there should be some understanding between the phosphate manufacturer or the supplier and the client, your client, the customer. Then surfactant choice. So this is another aspect where you can use acid and oxidizer stable non-ionic surfactants. You can use a pluronic acid also. So I can suggest because I have already experienced by using this pluronic. So this gives better results also, but it should be in low dosage. And finally, that is the best alternative recommendation. So there are 2 points to be discussed. One is use chlorate or nitrate in a single pack system. Otherwise, you can have two pack system where you can keep nitrite as a separate second pack so that long shelf life is needed here, and the stock is also stored in warm or that is uncontrolled environments. So these are all the major issues, and that can be solved by adopting the suitable uh, techniques. Okay, so let us understand the complete chemistry of this phosphating. So you please watch my phosphating series where I will talk about more on the that is chemistry issues and chemical engineering day-to-day problems encountered by the phosphators. So these series of lectures will be very useful to both the phosphate chemical manufacturers and the end user and powder coaters and electroplaters also. So please follow my channel regularly. Please subscribe and share with your friends also. Thank you.